As you know, a half cell. Whenever a metal rod is deep in its salt solution, for example, if zinc rod is deep in Zn2 positive solution, then it is known as a half cell. Remember this point. Now on this half cell, either oxidation or reduction reaction takes place. And electrode on which oxidation reaction takes place is known as anode, whereas electrode on which reduction reaction takes place is known as cathode. For this kind of reaction, Nernst equation is written as E is equal to E0 minus 2.303 RT upon NF log to the base 10 concentration of product divided by concentration of reactant. Whereas at 25 degrees centigrade, value of 2.303 RT upon F is 0.0591. So this equation becomes E is equal to E0 minus 0.0591 upon N log to the base 10 concentration of product divided by concentration of reactant. Now we are going to discuss construction and working of 3 indicator electrodes and 1 reference electrode. Indicator electrodes, especially hydrogen electrode, green hydrogen electrode and a glass electrode. An example of reference electrode is a calomel electrode. Now let us discuss these points. This is the hydrogen electrode. In this way, in a HCl solution, a jar is placed and there is a platinum wire at the bottom of which there is a platinum strip. This platinum strip is covered with platinum black and this jar is filled with unknown HCl solution. This is the construction of this hydrogen electrode. अब यहाँ पर होता क्या है कि जो हाइड्रोजन गैस हम बबल करते हैं वो प्लेटिनम स्ट्रिप पर डिपॉजिट होता है और ये HCl सॉल्यूशन है, यानी H2 को डिप किया है H पॉजिटिव सॉल्यूशन में. जैसा हम कहते हैं कि मेटल रॉड इज डीप इन इट्स साल्ट सॉल्यूशन, सेम फैशन यहाँ पर क्या हो गया कि H2 को डिप किया H पॉजिटिव सॉल्यूशन में, यानी ये हो गया हाफ से. अब इसका वर्किंग डिस्कस करते हैं. सबसे पहले यहाँ पर ऑक्सीडेशन रिएक्शन इस तरह से होगी, यानी H2 इट गिव्स ट्वाइस H पॉजिटिव प्लस 2 इलेक्ट्रॉन. तो नर्स्ट इक्वेशन आपको पता है E इज इक्वल टू E0 माइनस 0.0591 अपॉन N log to the base 10 concentration of product divided by concentration of reactant. As you know, this is Nernst equation at 25 degree centigrade. तो यहाँ पर ऑक्सीडेशन रिएक्शन हो रहा है, इसलिए ये जो हाइड्रोजन इलेक्ट्रोड है इसके लिए नर्स्ट इक्वेशन रहेगा E oxidation is equal to E0 oxidation minus 0.0591 upon, here number of electrons are 2, that's why N is equal to 2 log to the base 10 concentration of H positive ion square divided by concentration of H2 gas. अब यहाँ पर H2 गैस जो है वो 1 एटमॉस्फेरिक प्रेशर का है, इस वजह से concentration of H2 is equal to 1 हो जाएगा. साथ ही में यहाँ पर देखिए हाइड्रोजन इलेक्ट्रोड अगर हम सोचते हैं तो इट इज़ यूज एज ए रेफरेंस इलेक्ट्रोड. इस वजह से अगर आप इलेक्ट्रोकेमिकल सीरीज में अगर देखते हैं तो इसका स्टैंडर्ड ऑक्सीडेशन पोटेंशियल ये रहता है 0. इस वजह से यहाँ पर लिखा है E ऑक्सीडेशन इज इक्वल टू 0, दैट इज स्टैंडर्ड ऑक्सीडेशन पोटेंशियल ऑफ हाइड्रोजन इलेक्ट्रोड इज 0. So in this way, this equation becomes E oxidation potential of hydrogen electrode is equal to minus 0.0591 upon 2 log concentration of hydrogen ion square. Now use property of log here. As you know, log A raised to power B is equal to B into log A. तो इस हिसाब से ये 2 जो है यहाँ पर आ जाएगा और ये 2 कैंसिल हो जाएगा. So this equation becomes E oxidation is equal to minus 0.0591 log concentration of hydrogen ion. अब जैसा आप जानते हैं pH यानी क्या होता है, सो pH की डिफिनेशन है कि pH is equal to minus log to the base 10 concentration of hydrogen ion. इस हिसाब से ये जो माइनस है और log of concentration of hydrogen ion है इसका वैल्यू आप पुट करो एज ए pH. सो दिस इक्वेशन बिकम्स E oxidation is equal to 0.0591 pH. This equation is known as Nernst equation for hydrogen electrode. and it is used to determine pH as well as for determination of concentration of hydrogen ion that we are going to discuss in the next video. Now later discuss queen hydrogen electrode as an indicator electrode. In a jar, a platinum wire is inserted and a pinch of queen hydrogen is added. Then it constitutes a queen hydrogen electrode. Queen hydrogen is nothing but equimolecular mixture of quinone and hydroquinone. As you know, this is hydroquinone and this one is a quinone. Now here oxidation reaction takes place like this. That means H2Q, it gives Q plus twice H positive plus 2 electron. As you know, this is loss of electron, which is nothing but a oxidation reaction. Now you know Nernst equation, E is equal to E0 minus 0.0591 upon M log to the base 10 concentration of product divided by concentration of reactant. Now this is product side and this one is reactant side. So this equation becomes E oxidation of queen hydrogen electrode is equal to E0 oxidation queen hydrogen electrode minus 0.0591 upon 2. Now here see number of electrons are 2, that's why value of N is 2. Log to the base 10 Q into concentration of H positive square, that is product side, divided by concentration of H2Q. Now since this is equimolecular mixture, that's why Q and H2Q it get cancelled because both concentrations are same. So therefore this equation becomes E oxidation is equal to E0 oxidation minus 0.0591 upon 2 log concentration of H positive square. Now again use property of log. Log A raised to power B is equal to B into log A. So according to that this 2 becomes here and 2 get cancelled. So this equation becomes E oxidation is equal to A0 oxidation minus 0.0591 log to the base 10 concentration of hydrogen ion. Now as you know, minus log to the base 10 concentration of hydrogen ion is nothing but pH. So put value you get E oxidation is equal to E0 oxidation plus 0.0591 pH. The standard oxidation potential of queen hydrogen electrode is minus 0.69. That's why here this value is put. So E oxidation is equal to minus 0.69 plus 0.0591 pH is a Nernst equation for queen hydrogen electrode. Now let us discuss glass electrode as an indicator electrode. So in this way this is a glass electrode. Here this bulb it is made up of semi-permeable membrane and filled with one normal HCl solution, whereas a platinum wire is inserted up to bottom and this one is unknown HCl solution. Now this is construction of glass electrode. Now how it works? Now here H positive ions are present. So these H positive ions come out from the semi-permeable membrane, whereas H positive ions from the solution get in through the semi-permeable membrane and thus a potential is developed across this bulb. This is the principle of glass electrode. So here oxidation reaction occurs as H2, it gives twice H positive plus 2 electron, that is number of electrons involved in cell reaction are 2. Now you know Nernst equation E is equal to E0 minus 0.0591 upon N log to the base 10 concentration of product divided by concentration of reactant. So this equation becomes E oxidation is equal to E0 oxidation glass minus 0.0591 upon 2, because here number of electrons, that is value of N is 2, log to the base 10 concentration of H positive square. Now use property of log. So this equation becomes E oxidation is equal to E0 oxidation minus 0.0591 log of concentration of hydrogen ion, because as you know these 2 and these 2 get cancelled as we discussed in the previous slides. Now as per definition of pH, pH is equal to negative logarithm to the base 10 of concentration of hydrogen ion. So by putting this value, you get E oxidation is equal to E0 oxidation plus 0.0591 pH. This equation is known as Nernst equation for glass electrode. So this is all about indicator electrode. Now let us discuss the reference electrode. So calomel electrode, it is used as a reference electrode. Now let us discuss construction of calomel electrode. So this is a glass tube having mercury at the bottom. This is paste of mercury and mercurous chloride. Further, this tube is filled with KCl solution. So whether it is saturated KCl or one normal KCl, this calomel electrode is of two types. One is a saturated calomel electrode and another is a standard calomel electrode. Calomel electrode filled with one normal KCl solution is known as a standard calomel electrode. This is a salt bridge and this one is inlet for KCl solution. Now let us discuss how it works. This is the reaction takes place on this electrode. Now here you see electrode may act as an anode or it may act as a cathode according to situation. Nernst equation for this calomel electrode is written as E is equal to E0 minus 0.0591 log to the base 10 concentration of Cl negative ion. Now here if we fill saturated KCl solution, then EMF produced by this cell is minus 0.24 volts. Whereas if this KCl solution is having concentration 1 normal, then here EMF produced by this cell is minus 0.28 volt. Thank you for watching this video.